We have seen many images of the planets, but we very rarely know if what we are seeing is totally real, has been manipulated, or has a filter. New research from the University of Oxford has corrected some. We have seen many images of the planets, but we very rarely know if what we are seeing is totally real, has been manipulated, or has a filter. New research from the University of Oxford has corrected some of the images of the planets Uranus and Neptune, captured by Voyager in the 20th century, and has discovered that much of what we knew about these planets was enhanced with other colors. Today you are going to the latest unpublished images that you did not know of some planets in our solar system. And not only that, you will see the surprising change that planets with dense atmospheres experience over time. Mars. Our journey takes us to the outer solar system, where Mars, Jupiter, Saturn, Uranus, and Neptune are located. For decades, the actual appearance of Mars has caused much controversy. Mars is known as the red planet due to its characteristic red-orange color, which is visible even with the naked eye from Earth. This color is mainly due to the presence of iron oxide, commonly known as rust or rust, on the planet's surface. This iron oxide gives Mars its reddish hue. Photographs from NASA, ESA, and other sources have only increased the confusion. From the black and white photographs of the Mariner 4, the reddish ones of the Viking, to the current rovers, the appearance and color have been changing. We have even seen the blue sky on Mars, so what is the real one? The planet has a surface with a variety of geological features, including plains, canyons, mountains, and craters. Some areas have a lighter color, while others show darker tones. The visual appearance of Mars can vary depending on several factors, such as solar illumination, atmospheric conditions, and the presence of dust storms. Space missions such as those carried out by rovers such as NASA's Spirit, Opportunity, Curiosity, have provided detailed images of the Martian surface and have contributed significantly to our understanding of the planet's geology and atmosphere. For decades it has been thought that the color of the surface and sky was intense red. The truth is that it looks a lot like some deserts on Earth. Here we see the appearance of Mars according to the Chinese Tianwen-1 probe, very similar to NASA's rovers. The surface color is ochre and can range in color from beige to dark brown. The color of the sky most of the day is salmon-colored. Due to its weak atmosphere, clouds are barely visible. Sometimes the sky turns blue, but it happens at sunset. A phenomenon known as scattering occurs on Earth. The atmosphere scatters sunlight in all directions, but scattering is most efficient for shorter wavelengths, such as blue and violet. This results in blue light being scattered in all directions, and is what we perceive as the blue color of the sky. On Mars, the atmosphere is different to that of Earth, and although it contains dust and particles, it can also scatter sunlight in a similar way. During the Martian day, when the sun illuminates the Martian atmosphere, the scattering of blue light can make the sky appear blue. This is what Mars looks like from the James Webb Telescope. The telescope cannot capture real or close images to our view, since it is an infrared telescope. And at these wavelengths it can capture more detail to study phenomena such as dust storms, weather patterns, seasonal changes, and other events. If you took photos in visible light, many of them would go unnoticed. An example of this is the analysis of the surface by the Perseverance Sherlock instrument, which has allowed us to take advantage of the opportunity to analyze the composition of Martian rocks from different spectra. Using in conjunction with the Watson camera, Sherlock has managed to detect the spectral signature of substances organics in some rocks. Mars experiences seasonal changes such that it sometimes turns yellowish due to dust storms that can last for weeks. Mars may undergo many other changes. What we know for sure is that its satellite Phobos will fall into the Martian atmosphere within 10.4 million years, but before that, in about 7.6 million years, when it is only 3,620 kilometers from the surface, it will be destroyed due to tidal forces and will create a ring. If we are still here, something very unlikely, we would see Mars become a ringed planet. Jupiter. We arrive at Jupiter. This is the Voyager image, very similar to the real thing but somewhat contrasted. This is the Hubble Space Telescope and James Webb and infrared spectrum. We come to the spectacular images captured by the Juno probe of Jupiter. These images look like watercolor, as if they were a painting. The truth is that almost all of Juno's images have been processed, altered and manipulated in order to better capture the details of the planet Jupiter. If we were there, we wouldn't be able to see so many details of its surface. This image is of a reddish storm that looks like something out of a work of art, 20,000 kilometers from the surface, with winds of up to 1,450 kilometers per hour. Jupiter does not have a solid surface, but it does have 3 cloud layers of different composition. The white colors are from ammonia, the browns from ammonium hydrosulfide, and a lower layer of water clouds. The red colors are due to the presence of organic compounds. The truth is that if we were there, we wouldn't see any of this. There would be less vivid colors. The clouds would not be appreciated with such resolution if it were not for the filters and spectra at different wavelengths. We would miss great wonders of the cosmos. Another significant fact is that Jupiter is slightly changing its appearance. The Great Red Spot is a large anticyclonic storm that has been waning for the last 150 years. This is how Voyager saw it 40 years ago, and this is what it is like now. Jupiter will continue to undergo changes over the next few million years. The most significant will be when the Sun increases its size and radiation as it ages. Now Jupiter is dominated by its internal heat. But within 5 billion years, Jupiter's cloud bands will be much narrower, and the winds will spin very quickly due to the heat received. Another important point is that some of Jupiter's satellites, such as Europa, can become habitable. Saturn. Saturn is an incredibly beautiful planet. It has been captured by Voyager's cameras, but with a lot of contrast and exaggerated colors. This is how the Hubble Space Telescope closest to our view captured it. This other photograph is from the James Webb Space Telescope in infrared. The Cassini photos look more like our view and reveal an orange world with a ring system. The clouds seem less significant than on Jupiter, although its winds are usually higher than those of Jupiter, up to 1,650 kilometers per hour. On Saturn, its clouds are usually more dispersed and different altitudes are not found compared to Jupiter. Additionally, on Saturn, clouds may be composed in part of water ice crystals, which may affect their appearance. The appearance of beautiful Saturn will also change. Its icy satellites may be habitable in billions of years, but in just 300 million years it will lose its rings. The impressive rings are pulled towards the planet due to its gravity and the influence of its magnetic field. Scientists believe the ring system is no more than 100 million years old, meaning we are witnessing a cosmic oddity, a beauty in our ephemeral existence that we can only admire. Uranus. When Voyager 2 reached Uranus in 1986, the photos were disappointing. An ice giant without any significant detail on its surface. We were presented with a planet with a pale blue-green color. This is the appearance that the Hubble telescope gave us, and this other photograph from James Webb, which shows much more detail thanks to the infrared resolution, but it is evidently not what we would see if we were there. Because Uranus has very faint rings, it has been presented in many photographs with these rings and more enhanced colors. But what our eyes would see does not do justice. Professor Owen and his colleagues have processed the original images of Uranus by Voyager 2 and compared them in 2 filters, 467 and 551 nanometers, and those from the Hubble Space Telescope's Wide-Angle Camera 3, taken between 2014 and 2022. The difference is not very significant, which shows that Voyager 2 was very close to its real color. They have also determined that Uranus appears more greenish in its solstices. That is, in summer and winter, which is when one of the planet's poles points towards the Sun, but during its equinoxes when the Sun is at the equator its color tends to blue. We have made the big difference in Neptune. Neptune. For decades, Neptune was shown to us in an intensely bright blue that NASA enhanced to better reveal the clouds and the spot. Following the same editing technique, researchers have revealed to us a color much more similar to Uranus than we thought. The images from the Hubble Space Telescope already made us suspect something strange, but even so the researchers continued to enhance the color to make it look like the Voyager images. Here we see Neptune captured by the James Webb Infrared Camera, where a large amount of detail is observed. We have known the truth thanks to the study of the measurements of its brightness that were recorded by the Lowell Observatory in Arizona between 1950 and 2016 in blue and green wavelengths. This is the actual color of Neptune. The serious thing about the matter is that many people believe that Neptune had an intense blue color, and there are many documentaries with the saturated color of Neptune. Same thing with Mars, we've been wrong for decades. The confusion was that Voyager captured the planet in 3 different colors and it was not accurately compensated. Scientists are interested in seeing as many details as possible, far from being considered aesthetic or realistic. Thanks to data from the Hubble Space Telescope Imaging Spectrograph and the Very Large Telescope Multi-Unit Spectroscopic Explorer, European Southern Observatory, we have compared the images of both planets and they are similar, although Neptune is still somewhat bluer than Uranus, due to the high methane clouds that absorb the red color. It is far from that intense blue color that we all knew. Uranus is less bluish due to a greater thickness of methane ice particles that are more dispersed. Professor and astrophysicist Catherine Hamans commented that scientists 40 years ago did something that everyone can do today: retouch colors. Once again, we wonder what it means to define the real color in an astronomical image. It is common for telescopes and space probes to highlight features that would be invisible to our eyes. The vast majority of images of the planets would have a very faint color if we saw them with our eyes. Our eyesight has evolved on Earth to capture certain colors and details of our immediate surroundings, but in the rest of the cosmos, our eyes are not adapted. Our professional cameras and cell phones are designed to imitate our eyesight and have been color calibrated to the Earth's lighting conditions, atmosphere and contrast, but no matter how hard we try, no camera is going to capture the details and color you see. Your eyes. The only way to realistically witness those planets would be if you were there. Surely the balance and appearance of our solar system will change millions of years from now. Everything must follow its course of renewal, from the ship Earth. At the moment, we can only contemplate the wonders of the cosmos through robotic eyes or filters that enhance the details and capture the dim light that reaches us from the cosmic wonder. Hush.